Welcome back. And before we start today, we've got a guest, Alex, from OS2G, which is a recognized student organization that is quite old now at this point. I think it's over 10 years old. And they focus on technology, focus on Linux, and he's here to tell you all about it to try to get you involved. So please, go ahead.
Hi, everyone. I'm Alex. I'm the primary programmer of OS2G. This might be a little hard to see, but is anyone familiar with this device? Yes, this is the Steam Deck. It's a pretty popular device. It's probably the most popular PC gaming handheld. And it's interesting why it is, because its hardware is not necessarily the fastest or the best. But what reviewers always tend to like about it is the underlying software, which is a Linux-based operating system that enables for much deeper levels of hardware configurations and battery life and performance. OS2G is very much centered around systems like this systems like Linux, as well as other open source software that is free to run, inspect, modify, redistribute, however you like. This next week, we will be doing an event known as the Linux Installathon. This is an event where people can come to Kiewit room A310, and they can basically bring either their computer or no computer, and we members will help you figure out what it's like installing Linux if you're interested in it. And if you're not comfortable with installing it on your own computer, you could also install it on some Raspberry Pis that we have, just to get an idea of what it is like. With Linux, you can have an operating system that is similar in its interface to Windows or Mac OS, or you could have something that's completely different from all of these. And more importantly, it will give you an sort of unparalleled level of privacy, freedom, and creativity. So if you're interested in joining us, we have a Discord server. Feel free to scan the QR code if you would like to check it out. We also have our website, os2g.club. And so it'll be Thursday, 6 to 8 p.m. At Kiewit Hall, A310. And we hope to see you there. Thank you.
Sure, thank you. And I highly recommend it because in the past they've had some really good speakers and really good technical talks. For example, you're using Git right now, but mostly you're using it to get started. You know, you clone a bunch of starter code. They'll get you into it deeper on how to merge, how to do branching, stuff like that. If you have a Raspberry Pi, bring it and install RetroPie or something like that and play some cool games. Thanks a lot.
Thank you, Dr. Burke.
All right, so picking it up where we left off last time, what we want to do is the last thing that we did was we organized all these books by author by making a map, right? We mapped a person to a list of their books, and then we built up that map. For each book, we got the author of that book, and then we looked in the map for that author, right? And if that author existed already, that is, we saw them before and we created a list so that it can contain the books, then we went ahead and added it. If it didn't, in other words, it was null, that's the first time that we've seen that author, we went ahead and created a new array list for them. Then we added that book unconditionally, and then we put it back into the map. Now, if I just output this, then it's one really, really long line that's really, really difficult to see. So let's go ahead and write code now to print it out in a nicely formatted manner. And the way that I'm going to do that is by iterating over each one of the keys in this map here, because we want to see all the authors and then their books. So for person P in the collection, what was it called? Book map dot. And how do I get the key values? Well, you can get the key set. If I want the values, then I can go with values, but I want the key set here. Because once I've got that key, that maps to the list of books that are by that author. So I've got the person. Let's go ahead and print them out. System.out.println P, right? And then we'll iterate through all their books. First of all, we have to get the books. Here's the list of books by that author, right? In fact, I'm just going to steal this code up here since it's exactly the same thing, except that we're not calling them author, we're calling them P, right? If we wanted to, arguably it would be better to call them author because that's what they are in this context. And we can do that really quickly by simply saying refactor, rename, and then I'll call them author, right? And it's changed everywhere that's referenced. Now, if I just printed out the list of books, again, it's going to be in one long line, not very pretty at all. So I'm going to go ahead and iterate over the books. For book B in the collection, books by that author. That's not a great variable name either, but whatever. Right? System.out.println. Now, to offset this, I'm going to add some nice formatting here. I'll tab over, and then I will go ahead and print out the book. Right? Okay. And that should get us done with the demo as long as it's correct, right? There we go. Let's go ahead and expand this out and go out all the way to the top here. And there's Octavia Butler. I only have one book by her here. We've got a problem here. I see two Carl Hyacins, right? And he's got Squirm and Chop. right? But they're not together. I wonder why that is. We'll come back and fix that. Otherwise, you can see the same problem here. Murakami and Murakami, right? I've got 2 books by him, but they're not collected together here. Why not? So let's come back over here, and let's start up at the top and just start walking through, okay? For each book here, we get the author, and we ask the book map, have we already seen this author here, okay? And there's actually an underlying bug. I believe that the underlying bug is in this line. And it's something that we're going to talk about when we switch over to object-oriented programming today, is that an object has to have identity. In other words, how do I distinguish between this string and this string? We've already seen that in practice that there's a problem there. If I have a string with apple and a string with apple, and I use equals equals to compare those, it's not going to say that they're the same thing necessarily. So how do I know that this object is the same thing as this object? Well, I'm trying to do this for authors, or I guess the persons. So let's go to the person class and think about what we've got in here. Remember that I made them comparable. That is, I've got this function down here that takes another person and then compares this person to that person. Right? I compare their last names, and if their last names are the same, in other words, that compare to method returns 0. Then I break the ties by looking at the first name, excuse me, and then I return that result. That's going to work for searching, sorting, and everything that we've done up to this point, but it's not going to work for identity. Like, for example, over here in this map, right? This map has a notion of an author. Well, there's this author class over there, but how do I know that that author is the same thing as that author over there? Right? Just like the strings, how do I know that the contents of that string is the same thing as the contents of that string over there? So I need to come over here to person, and I need to add some more functionality here to give objects identity, a way to distinguish between that author and that author over there. And to do that, I'm going to let the IDE do it for me. Let me come up here to source. Now we've already seen generate getters and setters. We've already seen toString method, and we've already seen constructors. Here is the other part that is kind of essential to all objects, a hash code and an equals method. I'm just going to let it generate based on the last name and the first name here. Okay. So don't worry about hash code. Basically, you'll get to hash-based data structures later on, maybe in Computer Science 3. Maybe here we'll talk about it. But basically, remember that this map is a hash map. It's using that function internally to determine where is that author, right? It basically takes that last name and that first name and boils it down to a single number. That's what this hash code is, right? And it's built in, and it's being done for us, right? What I really want to pay attention to here is the equals method. Now let's walk through this, right? It takes an object, right? And it says, is that object equal to this object? Well, first of all, they're equal if they're the same thing in memory, because there's no way to distinguish them, right? That's what this equals equals does here. If that object is null, but I'm not null, because obviously I'm inside the object, otherwise I wouldn't be here, right? Then they are not equal, because that one's null and this one is not. Then it checks, are they the same class? I don't want to compare apples and apples. I don't want to compare strings and persons, right? I don't want to compare strings and integers. If they're the same class, or if they're not the same class, excuse me, then they're definitely not equal. So we return false. Otherwise, we look at the first name and the last name, and if those are equal, then we say, yeah, for all intents and purposes, this author is the same thing as this author because they have the same last names and the same first name, right? And that's basically the same logic what we did up here, right? This will return 0 if the last name is equal to that last name and if the first name is equal to this first name. However, it's done in a completely different function, equals, right? Once I've got that, this probably should work now, hopefully. All right, let's go ahead and expand that. There we go. Frank L. Baum, the entire Wonderful World of Oz series right there. All right. Now they're all under one single author because that hash map couldn't distinguish that Frank L. Baum and that Frank L. Baum and that Frank L. Baum with a dozen different books, right? But now because I added that code that said that it's using that equals code to say, oh, that author is the same thing as this author over here, right? All right, cool. Let me go ahead and copy and paste this into the notes. And I'll push this out later today. But also I made changes to the person class here, so I want to make sure that you've got those too. There we go. And bear with me while I'm copying and pasting them. And then I'll commit these to the notes later today, or after I get back to my office. All right. All right, so that was basically a primer. It was an introduction to Java, but also it was a primer on how object-oriented programming works, right? Now we're going to look at it a little bit more in depth and detail, right? There are actually 4 pillars to object-oriented programming. 2 of them you're kind of familiar with already, and then 2 of them are going to be completely new. And then sometimes they say that there are actually 5 pillars, right? But no building has 5 pillars. The pillars are at the corners, right? So we don't call it a pillar, right? Recall that Java is a class-based object-oriented programming language. And the classes are going to be Java's way of realizing and implementing objects. That's the 5th pillar, right? If you have object-oriented programming, what do you have to start with? You have to start with objects, right? That means that in Java, everything is a class or belongs to a class, right? Now, if you're coming from a C background, you don't have classes at all. You have structs, but you also have functions, and functions don't have to belong to a class. Variables don't have to belong to a class. Variables don't even have to belong to a function at all. They could be global variables. If you're coming from a Python background, it's the same thing. Neither one of those programming languages is an actual object-oriented programming language. If you're coming from a Python background, you might have seen classes in Python. They were put there much later on as an afterthought. It is not a object-oriented programming first language. Java is. It was designed to be an object programming language from the start. Basically, a class allows you to model a real-world object, entity, or idea, right? So let's talk about objects in a little bit more detail here. Formally, there is a definition, and it consists of 3 things, right? Identity, and that is an aspect of the object that distinguishes itself from all other instances. A state, a collection of properties, elements, data fields, we call these member variables ultimately though. And then also behavior, that is the functionality that acts on that object's state or behavior, or state or data. Basically, what does the object do? What services does it provide? What are its methods at the end of the day, right? So these 3 things are now demonstrated in this one very simple class that represents a person. Less than 60 lines of code once I get rid of white space here. All right. First of all, that second aspect of it. What is its state? Well, in this case, its state is 2 variables. They're both strings, a first name and a last name. Okay. What is its behavior? Well, that's the 3rd thing down there. What is its behavior? What is the functionality that acts on that object's data? Right. Well, we've got a constructor. We've got a bunch of getters. We've got a toString method that formats the name and the last name, comma, first name, right? And then we've got this compare_to method that gives it comparability so that you can sort it and so that you can search it. But then finally, what's down at the bottom here, this equals in this hash code method? That's number 1, its identity. How can you tell that that object is the same thing as that object? How can you tell that that author, Frank L. Baum, is the same author as that author over there, right? Their first name and their last name are the same. They represent the same class. They represent the same thing in memory, right? All those things that we just went through. So we have all 3 of those things in this very simple class, right? And again, the identity is achieved in Java by generating an equals and a hash code method. Let me go ahead and bump this up to the top. There we go. All right. Communication between objects is done via message sending. All right. What that means is you're simply just calling the function, calling a function. You're invoking a function. For example, let me come over here to the demo. All right. All right. And let me go ahead and create a person here. Person P. I don't know. Let's call him John. All right. John is equal to new person. Right? I'm invoking the constructor there. John Smith. I forget what the order was, but maybe it's Smith John. I don't know. Whatever. Right? Now, how can I pass a message to that John function in order to execute its behavior, execute its methods? And we've seen this before when I say I have a function in the demo class. I go demo dot, and then whatever function is in there, or math dot sign, right? That's kind of sending a message, but it's a static function. Now what we have here is an actual instance of a variable, or of a class. If I want to get their formatted last name, like toString, right? I can go ahead and call that string formatted is equal to john.toString. Right? Now we hadn't actually called toString explicitly up to this point. We were just relying on Java to do it for us by system.out.println John, right? But now you can actually send a message to that object and tell it what to do. If we had something else, like say John dot say hello, right? And there was a function called say hello, that signal would be sent to that instance and then it would execute, right? And it's only slightly a little bit different than what you're familiar with just calling a function. But that's basically what it boils down to. You're simply sending it a message to invoke that function, okay? The communication is done through its interface, right? It's public methods. That's what an interface is, right? Private methods are useful. Private methods can be useful, but are not part of the interface, right? So if I go over here and I say, John dot, let's go ahead and add that method actually. Let's go ahead and have a method here called public void say hello. And all it's going to do is print system, oops. There we go. Print system.out.println hello, I'm John. Actually, I won't even do that. What I'll do is I'll go ahead and append this. All right. I'm Smith, comma John. All right. Let's come over here to the demo and let's go ahead and call that function now, right? Anything that pops up here is going to be part of the interface. Now, there's a whole bunch of other stuff here that's built into Java. For example, notify, toString, get class, etc. We're going to ignore that for now, and we're going to look at the interface that we're making. Say hello, right? Okay. Now, I'm sending, again, message sending. I am sending a message to John to say hello, and he'll say, hi, I'm John Smith. It looks like I got it backwards. That's going to be completely different from, say, a person named Jane equals new person. And here I'll go Smith, comma Jane. There we go. All right. And if I'm going to go ahead and get rid of that. And if I go Jane dot say hello, right? Remember that each one of those functions is actually acting on the data in that class. So they're not going to say the same thing. John is going to say, hello, I'm John. And Jane is going to say, hello, I'm Jane. Right? Why? Because they are two completely different instances in memory. Right? I'm calling the same function. And there is only one function called say hello. But they're owned by different objects. So I'm sending a signal to one object, I'm sending a signal to another object. Right? Now, private methods can sometimes be useful, but they are no longer part of the public interface. If I made that private, then I get a compiler error over here. Right? It has no idea what say hello is because it can't see them. Right? It's not part of the interface. Okay? All right. Objects are constructed rather than assigned. Right? Usually built-in types, built-in types, for example, like say int, right, are assigned because they're part of the language. If I go int a is equal to 42, then it's taking the value 42, translating it into binary, and storing it in this variable over here. You can't do that with objects. Instead, you have to define how is this thing created, right? And the way that you do that is, we've already seen, constructors, right? In Java, constructors are methods that are named after the class. They have no return value, and then they can take as many parameters as you want. As we saw a couple of days ago when we were doing this, if you do not define a constructor, a no argument, no parameter default constructor is provided by Java, right? Just like a lawyer. If you can't afford one, one will be provided for you. If you do define a default constructor, though, that one goes away. Or if you define another constructor, that default constructor goes away. You can have as many constructors as you want, and sometimes it's useful to utilize them as what are called copy constructors. I'll talk about that later on when we do another demonstration. Right? When you're designing your objects, even for this first assignment, hopefully you're doing an object like for a transaction or something like that, and then you follow these following principles. These are all acronyms that you might have seen before, but they bear repeating. First of all, the DRI principle. Don't repeat yourself, right? We offloaded the first name, last name to another class up here because a person is a completely different object. What if I had authors and editors and directors and actors, right? They're all people, right? Make one person class. Don't make 4 classes to represent each one of those different things, right? Make one of them so that you're not repeating yourself. That's what objects do, right? Instead of defining, a transaction as 9 different things, 9 different variables, take those 9 variables and put them into a class so you're not repeating yourself over and over again. YAGNI, right? Don't over-engineer your classes. YAGNI stands for you ain't gonna need it, right? For example, over here in the person class, I could have gone all out and said, well, a person is a last name and a first name, but also a middle name and an article and a suffix and a birth date and an address. And, I could have gone down that list. Like, maybe we're going to need that, right? No, you ain't going to need it. Keep it simple. And that's the last principle there, right? Keep it simple. I said simple, right? Keep it simple, stupid is that what that usually stands for. But just keep it simple, right? If you need to extend your object later on, like, well, now I need by person class to have an address, you can always go back and fix it, just like we did for book. At one point, we said we had the first name and last name in the book class, but then we thought, well, that's going to break because I'm not going to be able to organize things by author because there's no such thing as an author, right? Well, let me make a class that represents an author, and I pulled those 2 things out and put them into this other class over here, which is what I should have done to begin with, right? Okay, so we're eventually going to get to the 4 pillars next week, right? Those 4 pillars are abstraction, encapsulation, inheritance, and polymorphism. But what I wanted to do for the rest of the day is do one more exercise over here, right, in Java, okay? And this exercise is going to demonstrate why you can't just simply have a brute force, straightforward kind of solution in your assignment, in the third exercise of your assignment. So here's my exercise. I've got these 2 large files in my project here. Numbers A and numbers B, right? Kind of sounds familiar there. How big are they? Looks like they're over 109 megabytes, right? What's in them? Well, let me go ahead and list them. I'm not going to open them up in my editor here because they're too big, right? So what is it? Well, the first line contains the number of records that come after it, but otherwise they're just a bunch of numbers afterwards, right? And there's numbers.b.txt, right? And they're not the same numbers. Actually, they are the same numbers, but there's one missing. Which one is missing from this file, right? Now, there's no way that a human could do this, even in their lifetime. There are 10 million numbers in each one of those files. There's no way that you could go and sort them by hand. This is where a computer comes in. A computer can do that kind of large data crunching very, very quickly. So as a review, let's go ahead and open up those 2 files, read in all the data from each one of those files, and try to find out what number from the first file is missing in the second file, if any, right? There's actually only one because that's the way I did it, right? So first step, right, is to open and process each file, right? Okay, let's do the first one. All right, A, open the first one, right, ... Open and process the first one. How do I do file input? Hopefully you're doing it right now. Hopefully you've done it already, right? Remember, scanner, right? And I'll just go S is equal to new scanner, and I will be opening up that first file. That first file is contained over here in data numbers.a, right? But if you wanted to, of course, you could read those in as command line arguments. Let's do that way because that's how you're doing it in your project. Args, new file, right? Arg sub 1, actually, sorry, 0, because that's the first command line argument, okay? I can make another scanner here, S2 if I want to. Let's go ahead and go with S1 and S2. I'll just go ahead and open them up, both up. Scanner, new file, args1. Right? That's how you should be reading in your file names from the command line arguments here, right? Now it's not going to let me compile because you need to surround it with a try catch. right? Surround that, I'm just going to surround everything with a try-catch here. All right, there we go. All right. All right. And I when I'm writing code that opens up a file, I immediately like to close the file and then come back and fill in the middle because I'm going to forget that. S1.close, right? S2.close. Right? There we go. All right. So if I ran this right now, of course I would get an index out of bounds exception because there's no such file as whatever's stored in this thing. How do I set command line arguments? Remember, you go up to run configurations, you go over to arguments, and I've already got some in there, that's why it wasn't crashing, but I'll say data slash numbers.a.txt and data slash numbers.b.txt. Right? And I'll apply that, run it, and it should run, but it won't actually print anything because I haven't done anything other than open and close the files. All right, so let's go ahead and process each one of those files. Let's process the first one. Right? Now, don't ignore that first line, like in your project. Don't ignore the first line. That tells you how many lines you should be reading. What if the first line were 5, but there were 50 lines afterwards, and they were not formatted in the way that I expected? Use that first number. I'll call it n, right? Is equal to integer.parseInt of s1.nextLine. Basically, I'm getting the first line, and I'm parsing out that integer, and then I'm reading that as n. Now that tells me how many more lines I should actually read. 4. Why did I switch over to a for loop, by the way, instead of a while loop? Because I know how many times I'm going to iterate over this, right? For I is less than n, I plus plus. I'm going to read the next line. So string line is equal to s1.nextLine. Next line. There we go. Now what do I do with that line? I parse it out as an integer. So int x is equal to integer.parseInt line. Okay. Now what am I going to do with that x? I need to store it somewhere, right? That means that I need to create 2 lists. A list of integers, right? Integer number, I'll just call it numbers A, right? Is equal to new array list. Oops. Okay. And this and a list for the second one, which I will call numbers B, right? That's just because they're in 2 different files. Okay. Once I've got x, I can add it to my list, numbers a.add x. Right? And I eventually close it down here. I am only reading exactly how many I should read. Right? Let's do that for the second file. Right? Now here I can't reuse the same variable name. Should I assume that they're exactly the same size? Not if there's one missing in the other file. So I'm going to call this m instead. And I'm going to be reading from S2. Make sure that you're changing everything. When you copy and paste, you have to make sure that everything that needs to be changed changes. Right? If you get good enough at coding, right, then you can do that. But usually, if you're just beginning, I would actually recommend not copy pasta in, right? Instead, just retyping everything so that you're sure to get everything, right? And then what else needs to change? B. All right. Did I miss anything? I don't think I did. Right? I'm certainly not going to print this out. This would be 10 million integers plus 10 million integers. I'm not going to print out 20 million things. Okay. But I can put in some debugging code here, right? Some sanity checks. System.out.println red, let's go with printf, red %d and %d numbers. End the line. And here I will go with numbers numbers dot size. That tells me how big of a list that I created, and numbers b dot size. Okay. Did I at least read in the correct number of lines? All right. And let's go ahead and run this. And it is going to take a little bit of time because we are reading in 20 million things here. If you want to, you can always add some logging code here, right? Loading data, ... right? To be sure that it's actually running, right? I look at that and I see 10 million, and I look at that and I see 9,999,999, and it looks like it works, right? Because if we, what was it, more A, there are 10 million up there. more B, there were 9 million and change over there. 1 million minus 1, one that's missing. Right? Okay, that's good. All right, and that ran actually in a reasonable amount of time for the amount of data that we were processing. Right? All right, now what do we do? Step 2. If I want to search through this, how should we go about doing it? Here's the naive way, right? Search through, or I guess, let me outline it a little bit more. For each x in A, right, determine if x is in B, right? That's pretty easy, right? And I'm just going to write a for loop to do this. For int x, actually, I'll go with a traditional for loop here. For int I equals 0, I is less than the size of the array of the list of numbers A, dot size, right? I plus plus. Okay, plus plus. Right? And now I've got my x, right? Int x is equal to numbers A dot get the ith element. I've got x now. That's an x that's in the first one. I need to go through all of the other numbers in B and see if it's in there. For int j is equal to 0, j is less than numbers B dot size, right? J plus plus. I'm using j because it's an inner for loop and I've already used x on the outer for loop. If numbers B dot get j is equal to x, and by the way, you can do that with numbers, right? Equals is perfectly fine here. Then I will say, oh, I found it, right? So found is equal to true, right? And I'll put in here Boolean, found is equal to false. I'll assume that it's not in there, and then if, I guess I need that up here, sorry. There we go. I will assume that x is not in there until I find it. And if I never found it, in other words, if not found, right, then I will say system.out.println missing x, or x equals, and then plus x. Right? Now this might be how you do it in like a CS1 course initially or naively, right? Let me go ahead and run this. System.out.println, searching, ... Okay. Let me go ahead and run this. And the loading of the data only takes, maybe 10 seconds or something like that. Once it's read, come on, there we go. All right. Oh, all right, we got lucky. All right. Darn it. But it's still going, right? I shouldn't have put it first. I just eliminated the first number that was there. All right, so we got lucky there because it was the first one, but the program is still running, right? There could be another one that's missing, right? What if I had taken out the last one, okay? Why is it still running? How many operations is it doing? How many times is this the for loop here executing? How big was this first one? 10 million elements, right? All right, well, how many times is this for loop executing? 9,999,999. Let's just say that it's 10 million, okay? So every time the outer for loop executes, the inner for loop executes 10 million times. How many total iterations is that going to be? 10 million plus 10 million? No. If I was doing 5 out here and 5 in here, what would it be? 5 for the first one, 5 for the second, 5, 5, 5. 5 fives, how many is that? 25. In other words, you multiply them together. 10 million times 10 million, how big is that? Isn't it, I don't know. What would you call that? Trillions, isn't it? Wolfram Alpha. So 10 million times 10 million. Hopefully it interprets that as million. Assuming, it's molar. No, moles. All right. 10, 1, 2, 3, 1, 2, 3 squared. There we go. What is that? Yeah, 100 trillion, right? 100 trillion operations. Is it going to reasonably execute in the, say, 1 minute that you have before your program is killed on the grader? Definitely not. In fact, how long is it going to take to execute 100 trillion operations here? Hours, weeks, days? Right? Probably days. Let's kill it. You have to think of more efficient solutions, right? So I'm not going to be able to do a brute force, straightforward, nested for loop like that here, right? Instead, what do I do? I use searching and sorting. Right? What is an efficient searching method that you've seen? Binary search. To make use of binary search, though, what do I first have to do? I have to sort them, right? Remember, binary search works by jumping to the middle and saying, oh, the thing that you're searching for is less than that, or the thing that you're searching for is greater than that. In other words, it cuts it in half every single time. 10 million elements are cut down to 5 million elements with one operation. 5 million elements are cut down to 2.5 million operations, or elements with only 2 operations. You keep cutting that down and it's exponentially faster. But it has to be sorted first, right? So numbers A and numbers B. I need them both sorted here. Right? Actually, I don't need numbers A sorted technically, but I'll go ahead and do it. Right? And I'll move searching down here. And I'll say that I am now up here sorting. Because sorting this many numbers is going to be a non-trivial amount of time. Right? So I want to see that in action. Once they're sorted, I can then go for each element x, for each int x in the collection numbers A. Right? That's a more that's a more compact loop. Before I was doing the index-based loop in order to highlight the fact that you are making 10 million iterations there. Right? It's less obvious with an enhanced for loop like this, but an enhanced for loop is a lot better. Right? And we'll see that why later on in the semester. All right, so for each element x in numbers A, I need to search for x in B, numbers B. How do I do that? Now that it's sorted, int index is equal to collections dot, what is that nice, it's right at the top. What is that nice fast function there? It's going to be binary search, and I'm searching numbers B for the needle called x. Remember, I don't have to provide anything else here because it's naturally ordered. It's built into the language. If you were searching, say, transactions, you would have to make your own comparator in order to do that. Now, a successful search will return something non-negative. If index is less than 0, then that means it was an unsuccessful search. System.out.println, and that's what we're searching for. Missing value, right, is going to be plus x. There we go. All right, we're probably going to still get lucky here because it is a small number, right? A reasonably small number. But let me go ahead and run this now. Right. Got to load the data, that'll take 10 seconds. Got to sort the data, that's going to be another 5-10 seconds. Searching the data, though, is going to be almost a blink of an eye. Right. So sorting. And here it's only going to be 10 million operations. We just have to go through all 10 million, perform a binary search on each one of those, and we're going to find that one single missing value, right, after we've sorted. There. We found it almost immediately, and it's done. Right? Do you see how much quicker that was? Right? That's because this is exponentially faster. Right? Yeah, we paid a little bit up front here to actually sort things. But now it's actually tractable. It's actually doable, right? If you try to do what we did at first with 2 nested for loops or some weird variation on that, it's not going to work, right? Because the number of records that we put into those test cases, some of them are smaller, just to make sure that like the one that we gave you in the handout and the one on the repo, it's only like 10 or 33 records. But the larger test cases have millions or tens of millions of records. All right, so that's the strategy that you need to take. Any questions? No? All right, then again, once we come back on Monday, when we come back, we will be have a guest from the Writing Center. We'll talk about technical writing and what you need to be doing for not this Friday, but for next Friday for your first draft of your design document. And then on Wednesday and beyond, then we'll come back to object-oriented programming. Okay? All right. I'll see you on Monday then.